Okay, so good evening. Welcome to Frontology TV Education Series. So I have a question for you. If, say for example, that you throw a ball horizontally, what will happen to that ball? Will it go straight all throughout or not? If not, then how would its path look like? Anyone? Okay, very good. Definitely, the ball will not go straight. Because, as shown in the diagram, as the ball travels horizontally, it is also being pulled downwards by the gravity. As a result, the path will not be straight, but it will be curving downwards. That leads us to our topic today, which is about projectile motion. Some pronounce it as projectile. Okay lang naman yun, walang problema. So, tayo mga Pilipino, kung paano yung kakasulat, ganun yung pag-pronounce. So, we pronounce it as projectile. Alright. So, in studying projectile motion, we are guided by the following learning competencies. So, galing po ito sa curriculum guide from DepEd. So, number 1, we have to deduce the consequences of the independence of vertical and horizontal components of projectile motion. And second one, calculate range, time of flight, and the maximum heights of projectiles. Specifically, it is expected that you, the learners, will be able to 1. Understand the essential concepts of projectile use, including the factors that affect the motion of a projectile. Then, you also have to appreciate the wide applications of projectile motion in daily life and perform experiments and solve theoretical problems involving projectile motion. Alright? So, let's go to the next one. What is a projectile? By definition, a projectile is any object wherein the only force acting is the force of gravity. So, yung object, ang tawag sa kanya, projectile or projectile. Kapag gumalaw ang isang projectile or projectile, definitely, ang tawag sa motion niya ay projectile motion or projectile motion. Tama ba? Okay. Very good. Next, let's take a closer look in the path of a projectile. Say, for example, may hinagis kang object at a certain angle or horizontally, then the path will be curved. So, it's either kalahati, kung hinagis mo yung object horizontally, so yung parang kalahati nitong diagram, yun yung magiging path niya. Okay? Kung hinagis mo naman siya or sinipa from a certain angle from the horizontal, then it will go up and then eventually it will go down following the same path. Okay? So, as a result, we can therefore conclude or we can therefore say that projectile motion is a type of motion that involves two dimensions. So, there is a motion along x. Okay? Specifically, uniform motion exists in the horizontal dimension or along x. On the other hand, along y, there is a uniformly accelerated motion. So again, what's the difference between the two? When we say uniform motion, again, ano ang constant dito? Very good. Constant ang speed. Ibig sabihin, the object covers equal distances in equal time interval. So as such, the speed is constant. Hindi nagbabago yung bilis, yung magnitude, yung speed, hindi rin nagbabago yung direction. Okay? So, kung forward, forward lang. Kung backward, backward lang siya. Alright? So, one last thing. And I think this is one of the most important concepts that you have to remember about projectile motion. that two types of motion in two dimensions involved in projectile motion occurs at the same time. They occur simultaneously, but they are independent of each other. What do we mean by that? The x component or the horizontal component of the velocity has nothing to do with how high the object will go. It will not determine the height or the maximum height of the object. Rather, the x component of the velocity will determine the horizontal displacement or the range of the projectile. In the same manner, the vertical velocity of the projectile will not determine how far the object will go horizontally, or will not determine the range of a projectile. The vertical component of the velocity is involved only in determining how high the object will go. Okay? So from that, we can say that although these two types of motion, along x it's uniform motion and along y it's uniformly accelerated motion, although they occur at the same time, they do not affect each other. They are totally independent of each other. Okay, so I hope everything is clear now. Now let's proceed to the next one. So in this part of the lesson, we will be exploring the experimental aspect of projectile motion. We will be using the PhET application. So this application can be accessed even if you are offline. Alright? So we will open the laboratory and we will explore the variables. How do the variables affect the motion of a projectile? Okay, so the first one is ginawa natin yung with air resistance and without air resistance. So ano ba ang difference? Okay, so syempre if you want to know the effect of a certain variable, you have to retain all the other variables, retain their original values. Okay, so ang babaguhin mo lang na value ay yung inaaral mong variable, right? Or yung gusto mong malaman yung effect. Okay, for example, variable number 1, air resistance. So magsimula tayo sa without air resistance. Ito, hindi siya naka-check. So without air resistance, what will happen? Ganito ang tsura ng path. Okay, so pwede natin yan i-zoom para medyo malaki. Okay, now let's try kapag with air resistance. So nakita niya, chinek ko yung part na to. So let's observe the trajectory. Okay, is there any difference? Okay, very good. Merong slight difference kapag ka merong air resistance. Ibig sabihin, if air resistance is present, then you will have a slightly shorter range for a projectile. Kumbaga, mas malayo yung makakating kapag ka without air resistance. Siyempre, alam niyo naman, air resistance is like friction, di ba? It opposes motion. So, siyempre, kapag mayroong air resistance, mas malapit lang yung makakating niya. Okay? So, that's one variable. So, next, we can reset this. Okay? Sa ating next na variable. So, yung next naman na variable na in-explore natin ay regarding mass. So, ano ba ang effect ng mass? Una, with air resistance, tsaka yung pangalawa, without air resistance. So, magsimula na tayo sa without air resistance. Okay, set ko muna na yung mass sa minimum value dito, 1 kilogram. And then, let's fire the cannonball. Okay, so that is the 1 kilogram without air resistance. Okay, now let's try the maximum value of mass, 31 kilograms. Dito sa application na to. And let's fire the cannonball. Okay, where did it land? At exactly the same spot. Therefore, we can conclude that without air resistance, mass will not affect the motion of a projectile. Okay, so now let's go to with air resistance. Tapos ganun pa din, yung mass ilagay natin sa 1 kg muna, minimum. Ganito yung magiging itsura. For 1 kg, that's the landing spot for a projectile whose mass is 1 kg with air resistance. Okay, next, let's try naman natin yung maximum value, 31. Tingnan natin kung saan siya babagsak. Okay, so with air resistance, mas malayo siya, mas malayo kapag ka mas mabigat. Okay, pero nearly nandun siya sa spot ng without air resistance. Tama? So bakit kaya yung sa with air resistance, yung mas magaan, mas malapit yung narating, yung mas mabigat, mas malayo ang narating? Okay? The explanation is yung inertia. So syempre pag mas mahina ang mas maliit ang mass, mas mahina ang inertia niya, mas madali siyang ma-oppose ng air resistance. Samantalang pag mas malaki yung mass, mas kinakailangan ng mas malaking air resistance para mapaikli niya itong path ng more massive na cannonball. Okay? So, next, reset ulit natin. Okay, so ang next naman na variable na titingnan natin ay yung effect ng initial velocity. Okay, so dito nyo makikita yung initial velocity sa bandang kaliwa. So, ang minimum na pwede mong ilagay ay 0 and ang maximum ay 30. So, syempre, hindi tayo maglalagay ng 0 dahil pag walang initial speed, syempre, hindi siya magla-launch, diba? Okay, so, we will instead use 10 meter per second as the initial speed. Okay, so, the rest of the variables, hindi natin gagalawin. And now, let's fire the cannonball. Okay, so that's for 10 meter per second the initial speed without air resistance tayo. Now let's try ganun din 10 meter per second pero with air resistance. Okay, so nakita ninyo hindi masyadong evident yung pagkakaiba pero may slight difference siya. Syempre pag may air resistance mas malapit ng konti. Pero almost exactly, maliit lang yung discrepancy nila in this case. Okay, now let's try naman kapag malaki yung value ng initial speed. So, without air resistance muna tayo. Without air resistance, okay, saan siya bumagsak? Yun, doon. Okay, so dito bumagsak yung object natin at kung ang initial speed ay 30 meter per second. Okay? Without air resistance. Now, lagyan natin ng air resistance. And let's launch the object. So, dito, most probably, mas makikita nyo yung discrepancy. Ayan, makita nyo, mas malapit ng konti. Okay? Ay, merong difference. Okay? Parang ganun din dito sa mahina, kaya lang hindi halos makita. Kasi nga, limited tong out. Okay? So, meaning to say, the initial speed, the greater the initial speed, the greater will be the range. Diba? That's what we can conclude from this activity. Okay. So, lastly, our next variable, reset ulit natin, ay yung projection angle. So, let's try at 80. So, try natin. So, wala tayong air resistance, ha? And, lagyan na natin sa maximum yung sige, wag na. Keep natin yung 18. Yun yung nakaset kasi dito. Okay. So, tingnan natin kung saan babagsak. Pag 80 degrees. Okay. Diyan bumagsak. Now, let's try. Kasi ang minimum dito, 25. So, try natin 25. Okay? So, ano masasabi nyo? Siyempre, range is a horizontal displacement. Ibig sabihin, kapag yung angle mo mas mababa sa gitna nito, kasi perpendicular yan. So, mas mababa sa 45. Let's say. Then, it will have a greater range compared to kapag ka mas mataas sa 45. Okay, kagaya ng 80 kanina. Okay, ito yung pinalabasan. Okay, ngayon paano naman kung eksaktong 45? So let's launch. Okay, nakita ninyo, the 45 degree angle will give you the maximum range. Okay, siya mayroong pinaka malayong makakating na range. Try natin yung 10 degrees. Diba, try natin yung 80. So what's the complement of 80? 10. Ay, wala pala tong 10, sorry. So 25 yung minimum. Ano ba yung complement ng 25? Okay, so compute 90 minus 25 is 65. Tama? So try natin sa 65. So 65. Hulaan nyo kung saan to babagsak. Okay? So let's take a look. Boom! Saan bumagsak? Kung saan bumagsak yung projectile nung naka 25 degree angle. Okay? So, yung 65 at saka yung 25, they are complementary angles. So, nakita ninyo na kapag complementary yung angle, they will have the same range. Kagaya ng 25 and 65 kanina. So, try naman natin sa another set of complementary angle. Halimbawa, 30. Okay? So, let's fire 30. Ito yon. Okay? How about kapag ka 60? Hindi naman siya babagsak. Boom! Dito rin. Kung saan bumagsak yung 30 degrees, dun din babagsak yung 60 degrees. So, ibig sabihin, complementary angles will result to say equal range, or they will cover equal range in that case. And the maximum range is attained at an angle of, kita nyo kanina, 45 degrees. Very good. Okay? So, yun yung FET application. So, pwede nyo itong i-download and then pwede nyo i-manipulate para makita ninyo yung effect ng bawat variables or bawat parameters. Okay? So, close ko na muna to. Now, let's proceed to the mathematical aspect of projectile. So, skip ko na yung derivation of formula. In my small channel, meron ako in-upload na video na about deriving the formulas for projectile motion. So, I suggest na panoodin nyo yun para alam nyo kung saan nanggaling yung mga formula na ipapakita ko in a little while. Okay? So, kung hindi nyo pa napapanood, panoodin nyo muna. Pero kung napanood nyo na, then much better. Pwede na tayo mag-proceed sa next part ng ating lesson. Okay? So, in summary, these are the equations for projectile motion na makikita nyo nga doon sa aking video. Okay? So, we have two cases for projectile. Case 1, objects thrown horizontally, and case 2 for objects projected at an angle. When the object is thrown horizontally, meaning to say that theta is equal to 0 kasi horizontal siya. Okay? Ito, syempre, hindi siya equal to 0 kasi projected at a certain angle. So, as such, magkaiba yung set ng equations or merong slight difference yung equations na gagamitin natin for case 1 and case 2. Okay? So, for case 1, kung ano yung binigay na initial velocity, yun na yung kanyang x component. At dahil horizontal to, definitely wala siyang y component, 0. Okay? And the formula for range will simply be equal to vx times t. Galing dun sa formula ng d or v is equal to distance over time. So, manipulate mo lang yon, you will have distance is equal to v times t. Or in this case, range is equal to vx times t. Then the height or the vertical displacement is simply equal to 1/2 gt squared since the initial y component is 0. So, cancel na yun sa kinematic equation natin. Matitira na lang ay 1/2 gt squared. And then, you can from here, you can derive another formula for solving the time, which will be equal to square root of 2h over g. Okay? So, ngayon yung case 2, medyo mas complicated. Pero kung mapapansin nyo, ito yung sa ating vectors. Merong x component and y component. Then, ito, time to go up is equal to time to go down to the same level. So, therefore, i-multiply mo lang to ng 2. Kaya naging ganito yung total time of flight denoted by capital letter T. Tama? And then, yung range natin, we have two options. Yung isa merong time, yung isa walang time. So, you can use either of the two to solve. Likewise, ganun din sa height. Meron tayong formula na merong time and then formula na walang time. So, this is sine squared theta. I-emphasize ko lang to. Sa calculator, wala kayong makikitang sine squared theta. So, ang gagawin nyo dito ay sine theta muna, tapos bago nyo i-square yung sagot. Tapos multiply 2bi squared. Okay? Para malinaw lang. So, these are the formulas that we will be using in order to solve the sample problems. Okay, now let's apply your mathematical knowledge of projectile motion into solving sample problem number 1. So, ano ba ang given? Diba pag nag-solve tayo ng problem, we always follow GUPSA or GRESA. So, given, unknown, formula, solution, and answer. Given, required, equation, solution, and answer. Okay? So, that's GRESA. So, ano ba ang mga given quantities sa problem number 1? So, we can give one. Very good. We have height equal to 22 meters. Another one. We have the range equal to 35 meters. Any other? Siyempre, it's a fact or understood natin that the acceleration is equal to negative of g or equal to 9.8 meter per second squared in the metric system directed downwards kaya negative or 32 feet per square seconds sa British system or sa English system. Also negative kasi directed downward. Okay? So ano naman ang hinahanap sa sample problem number 1? Kung babasahin nyo maigi, malinaw na malinaw, calculate the horizontal velocity. Meaning to say, Vx ang hinahanap. Okay? So, sulat ko na dito ay Vx. Kaya lang walang subscript dito, kaya Vx na lang ganyan. Okay? Is equal to unknown. Okay? Next, formula. Anong formula ang pwedeng gamitin to solve for Vx? Before you can answer that, kailangan mo muna i-identify kung anong case ba itong projectile natin. So, anong case kaya to? Case 1 or case 2? Very good. This is case 1. So, this is case 1. Case 1 of projectile motion. So, as such, sample 1 is case 1. So, as such, all the formulas for case 1 will apply. Okay? So, actually, nilagay ko lang yung solution dito para mas mabilis tayo. Tanggalin ko lang to. Yung mga nakalagay. Alright, so we have the range is equal to Vx times T. From there, we can solve for Vx and that is equal to R divided by T. Tama? Kaya lang wala din tayong time. So, in our solution and answer, we will have to compute for time first using the formula T is equal to square root of 2h over g. So, getting the value, we have the computed value for time is 2.12 seconds. Or pwede rin 2.1. Depende sa pag-round off mo. Okay. Next, therefore, ngayong meron na tayong time, or value ng time, we can now solve for Vx, which is the main unknown. And substituting the given value in this formula, 35 meters divided by 2.12 seconds, we will have 16.509 meters per second, or rounded off to whole number, we have 17 meter per second as our Vx. Okay? So, nasundan ba yon? Kung may tanong, paki-comment dyan sa comment section. Okay? Okay, now let's proceed to the next problem. Sample problem number 2. So, a projectile is launched at 32.1 feet per second. Ibig sabihin yan yung kanyang initial velocity and an angle of 52.6 degrees above the horizontal. How far did it go horizontally and vertically? So, following the group sa format again, the given quantities are initial velocity equal to 32.1 feet per second, theta or the projection angle is equal to 52.6 degrees. Of course, the acceleration is equal to negative g, but this time we will be using the equivalent value in English system or British system, which is 32 feet per square seconds. Then we are asked to solve for first, horizontal distance, which is range, and letter B, the vertical distance or the maximum height attained by the projectile. So, again, na-ready ko na yung solution para mabilis na tayo. Okay, tanggalin ko na lang. So, the formula in solving the unknown quantity for part A is this one. Okay, kaya lang hindi natin magagamit yung nasa taas dahil may time yon. So, we will instead use the other one. Similarly, sa part B, ganun din. You cannot use the equation with time. So, we will use itong nasa baba. So, now let's go to the solution and answer. For part A, we have R is equal to VI squared sine of 2 theta divided by G. So, substituting the given values, we will have 32.1 squared sine of twice the angle. So, multiply mo muna yung angle na 52.6 ng 2 bago mo kunin yung sine. Okay, tapos multiply mo si square ng 32.1. Then, yung sagot nun, divide mo ng 9.8. So, ang lalabas ay 994.36. Ay, hindi pala 9.8, 32 nga pala hanggang nagamit natin. So, 994.36 yung nasa taas numerator divided by G na 32. So, ang makukuha natin ay approximately 31 feet. Okay, rounded off yan sa whole number. So, our range is 31 feet. Okay, next, the maximum height using this formula VI squared sine squared theta. So, we have 32.1 squared. So, gaya na sinabi ko sa calculator, walang sine squared, diba? So, ang gagawin nyo muna, sine of 52.6 tapos quantity squared times itong square ng 32.1 ang makukuha divided by 2 times 32, so 64. Ang makukuha ang sagot ay approximately 10 feet yung maximum height. Okay? So, nasundan. Kung may tanong, paki-comment dyan sa ibaba. Next, it's your turn naman. Okay? Solve sample problem number 3. So, given tayo ng initial velocity and angle above the horizontal. Then, you are asked to solve for the time of flight. Ibig sabihin, total time of flight din, yung malaking T. And then, maximum height reached and the range of the projectile. Please comment your answers down below. Okay, now let's tackle about the real-life applications of projectile motion. So, let's begin. Whether you are into professional sports like basketball, golf, soccer, javelin throw, baseball, tennis, volleyball, and the likes, you are using the concepts of projectile motion. Or if some of your hobbies involve the following, like stunts, motorcycle stunts or car stunts, yung mga nagbo-motocross, or simply throwing a frisbee along the beach, or doing the parkour, there is projectile motion. Or if you are into military, where you are launching rockets or missiles, there is projectile motion. Or if you're a scientist that would like to launch a satellite in the outer space for improved communications or data gathering, then projectile motion is also involved. Or you are into the defense of your territory, then projectile motion is also involved. Or whether you are doing simple activities in daily life, like throwing a ball or anything, or simply watering the plants in the garden, or simply throwing a stone out of boredom into the sea, you are using the concepts of projectile motion. So that's how wide the applications of projectile motion is. Okay, so before we end this session, just a quick check. Did you learn something today? If yes, kindly comment it down below. And if not, then kindly give me some suggestions, okay? So with that, thank you very much for watching this video. Thank you and goodbye.